All right, everybody, we're going to be looking at systems of linear equations today, and we're going to be solving them through elimination. So on the right-hand side, I've put some generic steps to do this, and on the left-hand side, there is a problem. So the first thing we're going to do is we are going to line up our terms. So what you'll notice is the x's are set up, the y's are set up, and then the numbers are stacked. Okay, and then what we're going to do is we're going to look for inverse or opposite coefficients to eliminate. In this problem, we do not have that, but we are actually pretty close. You'll notice that there is a 6y in the first equation. Hopefully you can see that, and a 6y in the second equation. They are not opposite of each other's, but the numbers are the same, so 6 and 6. What we need to do is produce one of them to be opposites, meaning one is a positive 6 and one is a negative 6. So what we're going to do is we're going to jump down into step number 3, which is make the opposites by multiplication. So I'm going to choose the first equation to become a negative 6. And in order to do that, I'm going to have to multiply the equation by -1. And what I do to one side of an equation, I am going to do to the other side of the equation. So, and you'll notice I put the negative on both sides, and I'm going to distribute it in. So you notice -1 times -5 is positive 5x. -1 times positive 6y is negative 6y. And then we get 32 times -1, which is negative 32. Now notice we did not do anything to the second equation. It stays the same. So I just take that and I drag it down and I say, okay, 3x plus 6y equals to 48. Now at this point, because I have the opposites right there in the y's, I am going to eliminate. And how I eliminate is I just simply add the equations together. Okay, so 5x plus 3x is 8x. Negative 6y and positive 6y are 0 and cancels. And then we get negative 32 and 48, which is going to be 16 when we add them together. We're going to divide by 8. And x equals to 16 divided by 8, which is 2. Now, remember when we solve a systems of linear equations, we are looking for a coordinate point x and y. In this case, we found x, so we have the value of 2 in the x location. We still need to find the y portion of this coordinate. So I'm going to take 2 and I'm going to plug it into one of the equations. I'm going to use the second equation. So 3 times 2 plus 6y equals to 48. And what I'm going to do is simply solve. So 6 plus 6y equals to 48. I'm going to subtract the 6. That is going to give me 6y equals to 42. If you didn't see that, I subtract 6 from both sides. That'll give me 42. And then I divide by 6. When I do that, y will come out, and 42 divided by 6 is 7. And our answer should be 27. Now, of course, we do want to check our work. We always want to do that. So I can actually go to Desmos and I can type in the original 2 equations. And the nice thing about Desmos is you can type them in standard form. And I'm going to look for the line of intersection, or the point, I'm sorry, the point of intersection, which is 2, 7. And check it out. We came up with 2, 7 algebraically. The Desmos confirms that is 2 7s. And now we've done it both algebraically and graphically. All right, I hope that helps you out with getting into the steps of elimination and systems of linear equations.